Hello students, I'm back with the current topic, that is Centrifugation 1.2 in Pharmaceutical Engineering. My name is Grishma Dalal. This is the continuous portion of the last video, Centrifugation 1.1, where we saw basic of centrifugation. But in this video, we are going to focus on a little bit deep topic, that is what is centrifugation. You will get to know in deep by studying the various theories that depend on centrifugation. What is the difference between centrifugation and gravitational force, and why centrifugation is so much important in pharmaceutical engineering and all the experiment that you perform. So here is the theory of centrifugation. In a colloidal dispersion, the dispersed phase may be either a solid or a liquid. Particles having a size above 5 micrometers sediment at the bottom due to gravitation force. This you have to agree. This first point of theory explains that when gravitational force affects on any solution, the particles will settle down if the particles will have size above 5 micrometer. Right? You must have studied about sedimentation in your previous semester, that is it comes highly under suspension topic, so you might know what a sediment is and what the whole sedimentation process is, right? In such cases, separation of solid is possible by a simple filtration. You can easily separate solid by filtration. If particles are of order of 5 micrometer or less, they undergo Brownian motion. If they are less than 5 micrometer, they will undergo Brownian motion, and hence they will not sediment under gravitational force. Therefore, a strong force, that is centrifugal force, is applied in order to separate them. About Brownian motion, you will get to know in your coming semesters in the subject physical pharmacy. You will learn it really well, so focus on that topic. Just remember the difference here. If the size of the particle is less than 5 micrometer, they undergo Brownian motion and they do not sediment. If the size is more or above 5 micrometer, then they will undergo sedimentation. And you can compare it really easily here, because if the particle size, the bigger the particle size, the fast the sedimentation occurs, because the bigger particles settle fast due to gravitational force, right? Next, the sedimentation also depends on densities, as I explained, right? That because of the difference in the density, sedimentation works. That is between the dispersed phase and dispersed medium. If the difference in density of these phase is less, again separation is difficult. By applying centrifugal force, it is possible to facilitate. If you apply centrifugal force, then you can easily separate the any two phases, you can easily separate, right? Now there is this topic that is called centrifugal effect or relative centrifugal force, that is known as RCF. So consider a body of a mass m kg rotating in a circular path of radius r meter at a velocity of v meter per minute. So you have to just imagine a body that has a mass m, which is rotating in a circular motion with of radius r meters at a velocity of v meters. So here is the figure. This is the first one and this is the second one, right? Both the figures are almost same, only the presentation is different. There is nothing different in both of these, but it is just for your own comfort, so that you can understand easily. You can easily see here that there is a center of centrifuge R, centrifuge tube M, V, F, and the mass, or consider a body that is rotating in a circular way. So these both are almost similar. Now, the force acting on the body is radial direction is given by the force acting in radial direction, F is equal to mv square divided by R, where F is centrifugal force, right? So here R is, obviously it is the radius, right? The same body, now just imagine that the same body is experiencing gravitational force. Then how can you express it mathematically? Gravitational force G, capital G is equal to mg, where small g is acceleration due to gravity. This you might have studied in physics, right? The centrifugal effect is expressed as a ratio of centrifugal force to gravitational force. See, so here the force E, centrifugal effect, is equal to centrifugal force and gravitational force. Separating power of centrifuge is expressed as the ratio of centrifugal force to the gravitational acceleration. This ratio can be as high as 10 raised to the power 4. To clear your scene, or to clear your scenario, we are still going further in this topic. The centrifugal effect can be expressed as centrifugal effect C is equal to force acting in radial direction divided by gravitational force. But V is equal to 2 pi Rn, where n is speed of rotation, that is rpm or rps, right, of centrifuge. Substituting this equation, you will get C is equal to 2 pi Rn square gr, which is equal to 4 pi square r square n square gr, which is again equal to 4 pi square Rn square g. Remember this equation, because it will help you in getting the final centrifugal effect mathematical expression. Since 2r is equal to d, where d is equal to diameter of the rotation, substituting the value in equation gives. Now, as I said, the equation, the last equation, that is substituting this equation, you will need to substitute the value of 2r is equal to d. So you will get this equation: C is equal to 2 pi square d n square divided by g. If you see the past equation, then you have just replaced the 2r ratio, right? The gravitational constant has a value of 9.807 meter per second square. So equation can be simplified as centrifugal effect is equal to 2.013 n square d, where n is expressed in s raised to the power minus 1 and d is in meters. So ultimate equation here is this one, which will give you this is the final expression for centrifugal effect. The measurement of D is made from the free surface of liquid to the center of a centrifuge and should be mentioned while reporting centrifugal effect. So this is really important. You have to measure the value of D from the free surface of the liquid till the center of the centrifuge, right? From the equations, it can be in what you have learned from the past equation. Inferred that first is that centrifugal effect is directly proportional on diameter, which means it depends on the diameter of the centrifuge. The next is centrifugal effect, which is directly proportional to speed of rotation whole raised to the power 2, which means both of these inferences are really important in deciding how your centrifugal effect or your centrifugation will be successful. So this is it. In the next video lecture, we will continue with centrifugation in 1.3. So please stay tuned for the next video. Thank you so much.